Welcome back. This is again the continuation of correlation coefficient line of best fit. Now the next step is to make predictions. Quick recap. You find your correlation coefficient, check that if that's significant. If it is, you go one step further, find your line of best fit. What do I need the line of best fit for? That's what we're going to be looking today. Line of best fit is used to make predictions. Now, how can I make predictions? Let's take a look. When you're making predictions, you have two terms that you have to know. One is interpolation, one is extrapolation. Now, you might say, Miss, what does that mean? Interpolation is calculating the values that are within your observed values. Extrapolation is calculating the values that are outside your observed values. If it's an interpolated value, then it's reasonable and reliable. If it's an extrapolated value, it is unreliable, but sometimes it could be reasonable. I know none of this is making sense, but let's go ahead and take a look. I promise it will all make sense. Let's take a look at the example here first. I want you to read the example. In 2012, the CDC published data on average weight of American female children by year. So they did this experiment and they only used ages 6 to 12. So my data values or my observed values are 6 to 12, did I say? 6 to 14. So my data values here are only between 6 to 14. So what does that mean? If I'm using the line of best fit, I can predict the values that are in between 6 to 14. Okay? Now what are they saying? The researcher made a linear regression with ages in years and x variables and weight in pounds as y variables. Equation of the line of best fit is, so they already found the equation of line of best fit. According to the line of best fit, would you predict the weight would be for 18-year-old female? Is it reasonable to use the line of best fit to make the prediction? So once you find the line of best fit, you just cannot use it for any prediction. You have to see the predictions are reasonable or no. How do I do that? Remember what age did he take? He took from ages 6 to 14. But I have the data value for 8. Do you see that? I have a data value for 8. I have a data value for 10. I have a data value for 13. I have a data value for 14. Now you might say, Miss, you have all the data values. What predictions are you making? What if I want to find for 7? What if I'm going to change the number? What if I want to find for 7? What if I want to find for 9? What if I want to find for 11? So you see what's happening? I can use the best line of fit or the regression line to predict in between 6 and 14. If they ask me for 18, that's not in between 6 and 14. So yes, I can still calculate, but that's not going to be reliable. So I cannot calculate anything after 14 or before 6. In between 6 and 14 is interpolation. Outside 6 and 14 is extrapolation. So within 6 and 14 is reasonable and reliable. Outside is not reliable, but sometimes it's reasonable. Let's go ahead and take a look. Confusing? I promise it's going to be much better. Can you believe it's end of the semester? It's the last video. Okay. Erin is studying relationship between average number of minutes spent reading per day and math test scores and has collected the data shown in the table. The line of best fit, so what Erin did was he collected the data, he got the line of best fit, and according to the line of best fit, what would be the predicted test score for someone who spent 70 minutes reading? So look what they're asking you. Erin did the research, he got the line of best fit. Now they're asking you to predict for 70 minutes of reading. Now, first step, check if the 70 is within the range. What are your x values? Your x values are from 30 to 50. So step 1 is to write your range. Your x is 30 to to 50. Does 70 fall within the range? No, 70 is outside the range. So 70 is outside. What happens when it's outside? Outside the range is unreliable. You already know that because 70 is outside 30 and 50, it's unreliable. But still, they're asking you to predict. Let's do it. How do I predict? I plug the x value into the equation and find the value of y. What is my x value? What did they ask me to find for? 70 minutes. So my x is 70. Scroll, scroll, scroll. My x is 70. What do I do? Plug in. Y is equal to 0.8. Instead of x, I plug in 70 plus 51.2. I will get approximately 107.2. So my predicted test value is 107.2. Forget about stats. You take a test, out of 100 points, you get 107.2. Is that reasonable? Of course not. But we already know this is unreliable because it's outside the observed values. The data was from 30 to 50. This is the data given in the table, right? From 30 to 50. So if I have to find for 31, I can. 32, I can. So anything in between 30 to 50, I can. Outside, unreliable. Now let's go ahead and see. It's unreliable for sure. It's unreasonable also. There's no way you can get 107. So it's both unreasonable and unreliable. So this will be your answer. All right, next problem. The table, oops, where is the table? The table shows the data collected on the relationship between the average number of minutes spent exercising per day and math test. How interesting. The line of best fit for data. So whoever did this experiment, thank you. They already found the line of best fit. Again, you find the line of best fit when it is significant, remember, and there is a strong linear relationship. When there is no relationship, what's the point of predicting, right? It could be anything. Excuse me. So now you know that you have come to find the line of best fit only if there is a strong correlation. According to the line of best fit, according to the line of best fit, what would be the predicted test score for time spent in 42 minutes? Again, they're asking me to find the y value for the predicted 42. So as soon as they say predict for this value, I have to check if that value is in the range. So from 25 to 40. So my range is 25 to 40. So does 42 fall within the range? No, it's outside the range. As soon as I know it's outside, I know that this is unreliable, right? Now, but they still ask me to predict, so I'll do it. How do I do it? Plug x into the equation and find the value of y. I'm going to scroll this up. So my x value that they're asking me to predict for is 42. I'm going to plug into the equation. Y is equal to 0.44 times 42 plus 65.2. And that's approximately 83.68. That is my approximate answer. And once I have this is my predicted value. I know it's unreliable, but they asked me to predict, so I did, right? Now, getting 83 in the test, is that reasonable? Of course it's reasonable. So look what happened. In the previous case, we saw it's unreasonable and unreliable. In this case, it is unreliable, but it is reasonable. So you'll have all kind of cases in the data. So I know this is unreliable, but it's definitely reasonable. Yeah. So this is my second option. Unreliable, but reasonable. There you go. All right. Oh, I have one more. I didn't know that. Let's do this. The table shows data collected on the relationship between the average daily temperature and time spent watching television. I know as the temperature goes down, I watch a lot of TV. I feel so lethargic these days. The line of best fit for the data. So, whoever did this study, they found the line of best fit for us. And again, when they are finding line of best fit, what does that tell me about the correlation? That is significant. And it's a strong linear relationship. So, according to the line of best fit, what would be the predicted number of minutes spent watching television for an average daily temperature of 46? They asked me to predict for this value. As soon as they ask me to predict, what do? I go ahead and check the range. What is the range? 35 to 65. So 35 to 65. Is 46 in the range? Yes, it is in the range. So because it's in the range, what does that tell me? Inside the range is reasonable and reliable. Because they asked me to predict, let's go ahead and do it. I plug in the x value. What is my x value? 46. Where do I plug in? Into the equation and find the y value. So y is equal to 66 times 46 plus 88.5. 66, no, it's 0.66. I was like, 66 is a big number. So 0.66 times 46 plus 88.5. I get approximately 58.14. That is my final answer. Because the x value is inside the range, I know this is reasonable and also reliable. Now you see why I use my predictions so I can find the values in between. Okay, so this is both reliable and reasonable. The only option that has both reliable and reasonable is option number 4. There you have it. Again, if you have any questions, you can comment below or you can email me or reach me through Teams. Good luck.